So maybe I'll go ahead and get started. Welcome to the Hitchcock Center, everybody. My name is Jessica Schultz. I am Communication and Living Building Coordinator here at the Hitchcock Center. I've been here for about 7.5 years now, so I've been a part of this living building project for that entire time, pretty much. We've moved into the building about 2.5 years ago, so we've been settling in and enjoying it ever since and providing tours twice a month to our community for free. We have tours, and I'm saying this for the video purpose, we have videos, tours, first Friday of the month at 4 and the third Wednesdays at noon, and those are free. So who is the Hitchcock Center? How many of you already are familiar with what we do and who we are? Most people, but not everybody. Okay, the quick version is we are an environmental education center. We work with all ages, starting at pre-K up through adults. Obviously, we're all adults here today, so you're part of our community programs. We have a preschool program and after school, several after school programs. We have homeschool programs. We have field trips for local schools to come to us. We also have classroom programs, and our environmental educators go into the classrooms of local schools as well. What's next? So in building, so we were, before we moved to this site, we were just about 3 miles up the road. We were in an old carriage house, which was very homey and cozy, and in true New England fashion had the rope between the floorboards, as many of you may recall. But we were sort of stuffed into our little corners in our staff area, and we just had 2 classrooms in that building. We also leased that building from the town of Amherst. And when we decided to embark on this process of finding a new building for ourselves, we realized we weren't able to add on to that building in that location. There were some wetlands restrictions, some property line restrictions, things that made it a little bit challenging. So we decided to find a new building, and we were invited to consider this location at Hampshire College. We do lease our land from Hampshire, and we own our own building. But we have joined the Cultural Village here at Hampshire. So the Cultural Village is the Eric Carle Museum, the Yiddish Book Center, and the Hitchcock Center as well. So we're in our visitor center today. We welcome the community and families here. We start with our welcome wall, which I'm not going to go into detail on, but just briefly, we welcome people to think about how our energy comes from the sun and how composting toilets here at the Hitchcock Center are normal. Maybe they could be normal in more places than just the Hitchcock Center. There are others, of course, in the state, but all of the kids, everybody who comes here, of course, composting toilets are normal. We have a series of ecological principles that form the foundation of all of the programs that we do here at Hitchcock. They also form the foundation of the Living Building Challenge, which is the building certification that we are hoping to achieve with this building. So we're going to talk about the Living Building Challenge as we go on the tour today. I'm not going to go into a great depth on all of it, but we are going to touch on some of the more important pieces of it. So our visitor center, we have several different live animals. We have a painted turtle. We have a spotted turtle who's rarely seen. We have 2 3-toed box turtles, and we have a corn snake in the front. All of these animals are ambassador teaching animals, and we do take some of them to classrooms to teach from in our various curricula. We have all kinds of drawers and things to investigate for families and kids who come to visit. We have a library, we've got puzzles, games. We often have parents and small children coming in just to spend an afternoon or a few hours exploring here at the Hitchcock Center. We also have a basking boulder in our south-facing front window. It was a boulder that we excavated from the site here, and we placed in that south-facing window just to kind of help everyone envision if these animals were to come out into the sun and bask in the solar energy and get that passive solar gain. And what would that look like, and what would that feel like? It doesn't quite have that functionality for our building, but it does allow the kids to crawl on it and get that sort of sense of what that's like. So during our tour today, we're going to start with water. We're going to look at some of the building systems in our basement. We're going to talk about energy. We're going to talk about building envelope. And then we're going to talk about a little bit more about water at the very end. So I think we're going to, unless there are questions at this moment, I'm going to transition us to the next space and we'll start the conversation about water.
There's no wood turtle here, right?
There is no wood turtle here, no.
They're rare or endangered species?
They're either special concern or endangered. I don't remember the designation. Yes. Yeah. Yeah. Okay. Follow me, please. Okay. So we call this room our ecotone. An ecotone, in ecological terms, is a transition between different habitats. And here at the Hitchcock Center, it represents the transition from our south wing, where we have our open office area, our community meeting room, and our visitor center, to our north wing, which is our classroom wing, and also the wing that has most of our building mechanicals in it as well. But we thought this would be a really great space to start the conversation about water. And one thing I will say, as we transition, you'll feel that it's colder in here. This is an unconditioned space, which means it has no mechanical heating or cooling, except for some passive ventilation up over this beam. So we do have some rooms in the Hitchcock Center that are similar to this. The bathrooms have no heating and cooling, the Ecotone, no heating and cooling, and our storage area and our basement, no heating and cooling. So we were able to save some energy on those spaces. So here in the Ecotone, we decided to start the conversation about water on the floor under our feet. We walk around outside and we have a whole ecosystem under our feet. And here under our feet is the watershed that we live within, which is of course the Connecticut River watershed, or a portion of it. We start in the south with the Westfield and Chicopee rivers. We move up to the north. This is the Oxbow in the Northampton and East Hampton area. And just by your shoe there is the Salamander, which is where we're located here at the Hitchcock Center in that watershed. Quabbin Reservoir in the corner, which of course is in our watershed but supplies water for the city of Boston all the way across the state. And then we move north to the Deerfield and Millers rivers in the Greenfield, Montague, that area, and then on up into Vermont and New Hampshire. We do have a larger display of a little bit more of the watershed on the glass in the corner, but it's of course a very expansive watershed. So from the watershed we live within in the region to our local watershed right here on our site. When it rains at the Hitchcock Center, it rains into the building. Water comes in via the yellow pipe on either side from two different roofs. It goes into a black centrifugal filter in the corner, which takes out leafy debris, seeds, anything that might get through our roof drains. It goes into the green pipe and starts to fill these translucent tanks. We call these translucent tanks our first flush tanks. And the purpose of the first flush inside the building when it fills these tanks primarily is to give us a sense of how much rain we can collect. So 1/16 of an inch of rain across the surface of our roof equals 224 gallons across these 4 tanks. When these tanks fill, the water pressure pushes back against the green pipe and water can be diverted into the blue pipe and into our reservoir. We have a 6,000 gallon reservoir under the front lawn of our building, and that will be eventually the water supply for our building. Because we've had very rainy weather this fall, you all probably know we've had the rainiest fall in about 200 years, so we get some very heavy rains. So of course we have more than 6,000 gallons coming down, so water can also be diverted into the bioswale. And the bioswale is an engineered structure that allows water to naturally filtrate back into the earth. So for the purposes of Living Building Challenge, we cannot push water away from our site. We must manage everything that falls on our site on site because there is no way. We don't want to push it into a wetland. We want to, or a sewer system. We want the water to be managed on this site as if our building was not here. So putting it back into the bioswale is our closest approximation to doing that. Any questions?
How many gallons in the reservoir? You may have said
6,000. Yes. Mm-hmm.
And you said eventually will be a water supply?
Yes. So we're going to talk about our drinking water when we go down to the basement. Yes.
Now, this is an unheated space,
That's correct.
but everything's insulated. The windows are insulated, I'm assuming the roof is insulated.
Yes.
A lot of water in here, so it never, when we get down to -2 degrees, it never freezes in here?
So when these tanks fill with meltwater, which has to happen when the temperature on the roof is at a melting point, right? Then water will fill in here. So we've had some melting this week because we had some like 40-degree temperatures. And then the water will go down over a period of, say, 6 hours in these tanks. So it's never actually sitting in these tanks for
Okay.
long enough to freeze.
All right, so it's constantly circulating
Yes.
a little bit, so it won't freeze?
Yes,
But
exactly.
it's never gonna get that cold in here anyway, if you've got these air coming.
It shouldn't, but I can't tell you what the coldest temperature, if I was here at maybe 3 or 4 in the morning on our coldest night, I don't know what the temperature, we haven't tracked that, so I don't have that information. Any other questions at this point?
How do you get these to be all the way empty? 'Cause
They're
pipes are not at the bottom.
not at the bottom. Take a look inside.
Uh-huh.
So, so these tanks were designed, they're custom designed by our architect. We had Design Lab architects from Cambridge or Boston who designed our building. And our architect, Sam Batchelor, made a prototype in his backyard, connected it to his downspout and started testing it several months before he actually suggested that we do this display here. And then he said, hey, I've got this great idea. And we were like, wow, this is super. We all want to know. And when we first moved into the building, and even now, when kids are new to the center and it's raining, they come running in here because you can hear the rain coming into the tanks. And what does that look like? And how much can we collect? Because we can all see the puddles filling. We can all see the rivers. There's more water rushing. But what actually is that? How much is it? And none of us knew when we started this project.
And these aren't demonstration, these are,
This is our actual
The tanks.
water system in the
This is
building.
from all of the roofs?
This is from the north-facing roof on the south wing and the south-facing slope of the north wing.
So
So
they're still-
if you look at our building in profile, you'll see a short and then a long. Well, for the south wing, it's short, short, long. And so this is the long. And then it's reversed for the north wing. So the long sides are the collectors for our water system.
So I have a question. So this is an unheated space.
Yes.
Per code, you have to have insulation, a solid insulation throughout
Mhm.
between the unheated and the heated space, which you don't have. Plus that up over there
Interesting.
doesn't bring any heat in here
It
because
does.
heat rises. It's gonna be right up there. It's never gonna bring heat down here. So I find that kind of interesting.
That's a good question, and I'm not an expert on the code, so I can't respond to that in detail, but that's a great question.
I think the code requires the exterior walls to be insulated.
Between a non-heated and a heated, or a non-heated and a cooled, you still have to meet,
I'll be darned.
you still
I
have
should
to
know an
have.
architect.
And the glass that we have here, I mean, this would not be,
Well, it's
It's-
insulated glass,
but-
but you're talking about the
I'm
thermal.
talking about that
uh,
opening
Yeah, right.
that's over through,
mhm.
those
That's all in
openings you
wood,
have.
so that's-
No, there's a gap, there's a hole. That's what you said, that's where the ventilation air supposedly comes in.
But
So
also, the beam there is a wood beam, that
Would
would
not
have to
meet-
be insulated,
Right, it
because
would
there
not
would be a
meet
lot
the
of
code.
thermal.
yeah, I just find it interesting.
Probably
So.
Yeah.
don't sit, don't tell anybody about it.
You might have to put up drapes.
Or some glowing polyurethane.
something to blow the heat down?
Yeah, something.
All right.
Run that by solar?
I don't want to cut the conversation short on this. I'm not trying to hide from anything, but I am going to move us along. So feel free to keep talking about it. So I mentioned upstairs that the water system we saw up there was the beginning of our water system in the building. It will be because our own water system is not up and functioning. But I'm going to take you through it as if it is. So we have the reservoir under the lawn. It's going to come, the piping is going to come into the basement along that wall. It's going to come across the ceiling. You'll see 2 pipes across the ceiling, and one of those will have our reservoir water in it. It will come down and be brought into the filtration system via the pump here. We have a 5-micron filter, which is our first physical treatment of the water. We have calcite treatment, which changes the pH if our rainwater maybe is a little bit acidic. We have activated carbon filtration. We have 1-micron filtration. And then the primary treatment on the system that we're aiming for is ultraviolet light. Ultraviolet light renders bacteria incapable of reproducing, so we're still able to consume the water. Now, you might be asking the question, well, why not chlorination? Because every water system across the country depends on chlorination, unless, even if they're using ultraviolet light or any other type of treatment. So the Living Building Challenge asks us to do whatever we can in this building without the use of chemicals. So that extends to our water system as well, unless the local permitting authority says no. So we have to advocate to do it differently, which is part of the Living Building Challenge. They have an advocacy piece. And if they say no, then we have to go with chlorination. But if they say, well, try an alternative. If it works, then great. If it doesn't work, then you're going to go the traditional route. So we've been in the building 2.5 years. Why have we not gotten our water system up and running? Certainly we've had lots of rain. We have lots of water. That's not an issue for us here in New England. So there's a couple of things, and I'm going to branch out to the Kern Center next door, which is also a living building here on Hampshire's campus. And they've been working on their water system. They've had theirs up and running. And they've had several months in a row where they've had something called high HPC counts. What is high HPC? HPC is a measurement of the effectiveness of the treatment of chlorine on the water. So it's a count of colonies of bacteria and then the effectiveness of the chlorine on those colonies. And so there's a standard that's set for a public water supply. We have a public water supply here because we have more than 25 people in the building. So we're held accountable to that standard. And so for the Kern Center, they had these high counts and they had to come back off of their water and on to town water. And we saw that happening and we thought, we wonder if we're going to have the same problem as well. So we just thought we would wait and see how that works out before we bring our water system online. So we're still in the process because treating water is a difficult thing to do. And treating it with ultraviolet light is a difficult thing to do because what happens with chlorine is you start the treatment at the source, the water treatment plant, like here, and then there's a chlorine residual all the way to the tap. So that those colonies of bacteria are being treated and addressed all the way to the tap. But if you don't have that treatment all the way to the tap, then you can have colonies of bacteria building up at the tap. So that's one thing that we're resolving.
Why not use boiling it or reverse osmosis?
Mm-hmm. Good questions. And I don't know exactly. Maybe boiling it takes additional energy that didn't meet our energy goal. And I'm not fully up to speed on reverse osmosis
But
to
then
speak
you
to
still have
that.
the same issue that between the RO filter and the faucet, you could still have bacteria buildup.
It's possible.
And did you
Well,
say that
presumably,
you're...
if there's no bacteria that makes it past the UV, then there's no bacteria to grow downstream from it, is there?
Right, but it could
It
enter
goes
from the
backwards.
faucet.
Mhm,
Yeah, it could
mhm.
go back.
Go backwards?
Mm-hmm.
Oh.
So if you were to sample water from your system, how would it compare to town water?
Or Poland spring bomb.
Yeah.
Well, yeah.
That's a great question, and actually we're really looking forward to the day when we do bring our water online, so we can actually do like a taste test and maybe
You're not pumping water through it at all.
maybe a sampling test to see what the sampling.
And the other thing that's weird about it is we actually don't end up drinking most of the water.
Yes.
Right.
And
Good
so
point.
you
Mhm.
could have a final end stage process just for
Just
the
at the
drinking,
faucet.
right, at the
Mhm.
faucet.
Mhm.
But if you're feeding it to your
And
toilets or
Yes.
even your dishwasher, you probably don't.
Toilets.
Yes.
Yeah, but then
Well,
it would
that-
be easier to just do a separate gray water system.
Exactly,
Mhm.
yeah, that's
Yeah.
true.
Well, the interesting thing for me here is that this is a public water supply, there it is. And it functions in the same regulations, in the same set of supervision and regulations from the DEP that Amherst Water Supply at the Atkins Reservoir does, or anything like that. So you're taking hardware designed for acre feet of water, and you're putting a gallon or two through it.
Mm.
And if
Yeah.
the systems are not, we're reinventing, or inventing a whole new system here that can provide the same water quality standards as the Atkins Reservoir or whatever, the public water supply does. But the hardware to do it at this minute scale.
That's a
Doesn't
great
exist.
point, Chris. And I just want to, maybe everybody knows Chris, but Chris Riddle was our owner's project manager on the project, so Chris is very knowledgeable about our project. But I will take that point and transition to the fact that, we have these are filter housings, right? So the filters that go inside them, this is the activated carbon filter. So Massachusetts DEP would require us to change this filter 3 times a year. I believe, if I remember my statistics correctly, that this filter can handle 150 gallons a minute. So obviously we're a net zero building, that is net zero energy, net zero water. So our average water use in the building is roughly 35 gallons a day. So why did our engineers design a filter for our system that can manage 150 gallons a minute? Seems like a little over design. So our system, the system next door at the Kern Center has filter housings that are this big,
That you
and
can buy at Home Depot.
the filters are under $100 each. So when we discovered this, we said, we might want to do a slight redesign. So we have invited the engineer who designed the water system for the Kern Center to come on board to our project. He didn't originally design this water treatment system, but his knowledge is being built so much. He's become a local expert, and this is part of Living Building Challenge, to build local expertise in these alternative systems. So we're working with him and hopefully going through a redesign.
But if this system were in our home, it would be fine. It's, because we don't have 25 people living in our home.
Yeah, as
No,
long as you
but
don't
you
have a
still-
party.
It,
You still wouldn't use that much water.
oh, no, you're right.
Right.
But this would be overkill. I mean, but. it
Yeah,
would be-
because I mean, this is a surface,
It's, yeah, right. Our home-
this is a surface water supply, which is a little bit different. But, I mean, you could do that at your home too, but obviously many of us who live in rural areas, like myself, have well water. And I don't test my well water on a regular basis. Maybe I should. But, there is a difference there. So there could be some contaminants coming in as well.
There are something like 150 living building challenge buildings that have their plaques on the wall now.
There are 22
Oh,
fully certified
Oh, yeah.
buildings in the world right now.
Wow, and 2 of them in Amherst.
2 in
three of
Amherst,
them
yes.
are Within 5 miles of here. This is a hotbed of living buildings.
We have 4. We have 4 in Western Mass. 4 living buildings in Western Mass. There's 1 in Jamaica Plain. There's 1 being built in Dartmouth, South Dartmouth, right now on the South Coast. I can't remember the other projects in Massachusetts. Those are the ones that come to mind.
Is that UMass Dartmouth?
No, it's at the Lloyd Center for the Environment,
Oh.
another environmental education center.
When you think about it, was that the one at the Smith College, but it's not on the Smith College campus, it's north in Hatfield, West Hatfield.
Whately.
Whately.
Mhm.
And it has enough land area that it could have a well. And so they have a conventional well system. Didn't have to go through this whole go around with the public water supply.
And the John
It-
Over
it-
building isn't, John Over building is not a living building, is it?
It is not. They were aiming for LEED. They were aiming for a LEED certification. I don't know if they have it yet. The John Olver Design Building is at UMass. So if you haven't seen that building, I do recommend it. It's phenomenal. And it also, I will add to that point while we're on
Is that
it.
the building that
it's
you
a-
meant?
The John Olver Design Building?
At UMass?
Yeah.
Oh, I think you meant
It-
the John Oliver train station.
No.
Which is,
So the Hitchcock Center and the John Oliver Design Building have recently received honor awards for sustainable design from the Boston Society of Architects. So it's a very exciting new development. So I'm going to move us on just a little bit here to say that one of the main ways that we save water, conserve water in a commercial building like this is through our toilets. How many of you used the toilets already since you've been here? Everybody, awesome. So you're all familiar with foam flush toilets and you're all experts. Super, because that's one of the requirements of coming to our building, that you all contribute to our composting system. So if you, thank you for doing that. So as you know, there's 2 toilets in each bathroom upstairs. The waste comes down via the diagonal pipe into the Clivus composter below. The solid waste is composted in here. There's pine shavings. Then the human waste is contributed. We have beneficial bacteria that are added every 3 months. Clivus services these, so they do come out and add those. We did have worms added as well. I haven't checked in with them recently to see if they've continued to find the worms, but sometimes the worms don't make it, and then we have worms come from another composter, and we try again. So the solid waste is in the composter here. The liquid waste gets pumped out into these leachate tanks here. I have a question for you all, which is, why is this leachate tank more full than this one? Exactly. So we have more women that use the building than men, and so when we do have to have these tanks pumped out, we do pump on the schedule of the women's tank. Maybe we would have designed it a little bit differently had we known, but hey, you know, minor details. So I just want to show you our building dashboard briefly. Many green buildings have building dashboards so you can see how they function. And we do have this one up on our website, so you can access it there at any time if you want to see it. We did organize ours through the framework of Living Building Challenge. The challenge has 7 petals or categories, but they like to use the image of the flower, so they call them petals. And within each of these petals, there are a series of imperatives for a total of 20 imperatives. And each building that's fully certified has to meet all 20 of those imperatives. So I'm just going to touch on 3 of them because we don't really have time today to talk about all of them. But Living Building Challenge does aim to be a holistic building approach. So you'll see we have equity in place, health and happiness, and beauty here, as well as energy, water, and materials that I'm going to talk about. So just to touch on energy, you can see that we've generated some solar energy in the last hour. We've borrowed some from the grid and what we've used in the building. And of course today it's pretty gray. We've probably still got some snow on these panels above our heads. So we haven't loaned any. We're not net positive right now. We can dig into that data a little more. You can see in the green where our HVAC system starts up in the morning. The orange is our solar energy generation through the day. We can see that hourly. We can see it daily. You can see those 2, 3-ish warm days we had in February when our HVAC system actually turned off, which was very nice. And then we can see that monthly, and so you can see the height of the solar gain in the summer and then the low point in the winter. So just popping over to water briefly, we're going to have a similar thing here. We didn't have any rainfall yesterday. We don't have an update on our water because the information that goes there I actually read manually from our town meter downstairs, and I give it to the person who manages the algorithms for our site. So I didn't do that today. He's not on the job, and I'm not on that job right now. So, but you can see we have 6,000 gallons in our reservoir, a full reservoir. And because we've been reading the meter for almost a year now, I'm getting close to having a total on that, and I think we're going to be close to about 2 reservoirs for an entire year for our building.
12,000 gallons.
12,000 gallons. We did have an anomaly, so right now my total is about at 14,000, and that anomaly of 4,000 gallons was because we had a oops with our janitorial sink that got left on for about 24 hours at full force. So that was 4,000 gallons drained in 24 hours from our, well, not from our reservoir, but if it had been our reservoir, it could have been a little bit of a crisis for us. So I want to jump over to materials. We haven't really talked about materials in our building yet. For me, energy and water are certainly very important, but I think materials is equally as important. Our materials have to be sourced as locally as possible to our site to reduce carbon emissions and also to support local economies. Not everything is sourced locally, but for the most part, there's a certain percentage within certain radii. But the most important thing for me with materials is the red list. And for those of you who've gotten your daily Hampshire Gazette today, you'll see my Earth Matters column on materials in the Gazette. Every material in the building has to be vetted against this red list of toxic no-use chemicals and chemical families in the building, unless there's absolutely nothing else available. So when we were down in the basement, we talked a little bit about policy advocacy to change how we're managing some of our building systems. This is the market-based advocacy to change the building industry and to change the materials that we're using in our building. So just an example, I mean, we all know about asbestos, we know about lead and mercury. Some of these others might be a little bit newer to us. We see a lot of things now that are BPA-free. BPA-free might be great, but then you need to ask yourself, well, what do they use instead? Because this is chemistry, and chemistry is, well, it has a lot of alternatives. So instead of BPA, it might be BPF or BPS, and those chemicals may or may not be any better than what we're now free of. Formaldehyde, for an example, there's a case study with Hurricane Katrina in New Orleans where FEMA brought in trailers to house people who needed temporary housing. The materials in the trailer, I don't remember whether it was the composite wood board or the insulation, had formaldehyde in it. In hot climates, formaldehyde volatilizes. You cannot dissipate that with air conditioning. So people in these small confined spaces were exposed to extreme levels of formaldehyde. They developed respiratory illnesses and in some cases cancers as a result.
Until they've been shipped to like Alaska or something like that.
Until what?
Where they're in use. I mean, they just ship them somewhere else.
They have a lifetime, and then they go on to, I guess, a secondary or tertiary market, and they're supposed to contain a little sticker that says not for, home occupancy or something like that. But
Little sticker is the key.
But, well, frankly, it doesn't matter what the size of the sticker is, because if that's all you can afford, then that's what you're going to buy and you're going to live there. So those things can propagate themselves in time. I just want to mention one other while we're here, which is this perfluorinated compounds. Is anybody familiar with perfluorinated compounds? A little bit, yeah? Okay, so anybody familiar with Teflon?
Yeah.
Yeah, stain resistance, water resistance, carpets, fabrics on your couches, on anything you might have in your home. So perfluorinated compounds are behind all of those chemicals. They're also behind firefighting foams. So one of the big things that's happening right now is institutions like Harvard, Google, these big institutions who are purchasing a lot of products, a lot of fabrics, are trying to eliminate the purchasing of stain-resistant and water-resistant fabrics from their supply chains to get these products out of the supply chain.
Fire-resistant pajamas for kids?
Yikes, that sounds a little scary. But just, you'll see these in the news. We have contamination sites here in Massachusetts, in New York, in New Hampshire. There are sites across the country. You'll see these as PFAS, PFOA, and PFOS. And right now, there's a very good documentary I recommend called The Devil We Know, which really gets at some of the what the chemical companies knew about these compounds. and the class action lawsuit that sort of brought it out into the public sphere, and how everybody in the world may have these products contaminating their bodies.
We're seeing a lot of problems with firefighters.
Yes.
Because
Yes.
people be burning buildings and then
Yes.
the chemicals collect on.
Is
them.
it Boston that has the highest level of, or is it just Boston that's been, or Cambridge that's been researched that the firefighters?
I'm not sure, but I do know that in Cambridge we have higher rates. of,
Yes,
you know,
yes,
cancer.
yes. Yes.
What's the
Um,
foam in the foam flush toilets?
It's, I don't know exactly, except to tell you that it's a Naponal biodegradable alcohol-based soap. But Naponal doesn't really tell you much because that's the brand. The brand of the toilet is Nippon Toilet. So it does need to be a biodegradable soap to be in our composters.
And I just talked briefly about the struggle it is to try to build a whole building without using any
Yes.
of those red list
Mhm.
compounds.
Yeah.
One of them was PVC.
Mm-hmm.
Try finding something that anywhere that doesn't have PVC in it.
PEX,
What?
PEX.
PEX, isn't that PVC free?
No.
Yeah.
No?
But it is.
Yeah, I think it's PVC free.
Oh, it's
What's it-
everywhere in the building industry.
Right.
And so what Wright Builders, our builder, had to do was, working with the architects, find suitable substitutes for all of those things, and they're everywhere. It's a monumental project, delivering a building like this that's a healthy building that will not hurt either the occupants or the construction crews.
What did it increase in the cost?
We don't know. I mean, it's hard to really tangibly say. I've heard numbers from 5 to 20%. I don't know. There's certainly a cost premium because of the administrative cost, if for no other reason.
Mm-hmm.
The time it takes for the contractor to specify a product, to choose a product that's going to meet the specs and doesn't have a red list, and then it goes through an approval process for every little thing in the whole building.
And
It's a
this
very big
is
job.
is part of where Living Building Challenge is trying to change how buildings are built, not only in meeting this standard, but in doing so, building teams, the builders and the architects have to work together much sooner in the process, because if the architect is specifying 20 lighting fixtures throughout the building, and that building team is going to have to vet all those 20 lighting fixtures, and every piece of that lighting fixture has to be vetted. That's a huge burden. If they can reduce that number to 15 or 10 and simplify the building, then the burden of vetting all of those products becomes much easier.
When I talk about the declare list, that's important.
Yeah, so Living Building Challenge also has put together something they call the Declare List, Declare Label, which allows manufacturers to step forward on their own initiative to put together basically an ingredient label for their product. It doesn't necessarily mean that that it meets the red list and doesn't have any of those chemicals, but it does allow the industry to self-declare, and it's a starting point for teams. So to talk about the building structure, the timber framing of the structure is glue lamb or Nordic lamb. It's made of black spruce, and it's made of small pieces of trees that are glued together with a water-based glue to make a super strong engineered structure. We now have at least 3 buildings in Amherst that are made with this timber framing. The other buildings are all more than 1 story, so the timber framing in those buildings is much bigger and beefier than it is here. We have pressed plate trusses holding up our roof, very standard in construction. Not finished carpentry, but again, we're a teaching building, and so we wanted everything to be visible. We have a tongue and groove spruce product on the walls and on the ceiling. On the outside of our walls and roof, we have 6 inches of reclaimed polyiso rigid insulation. And then on the outside of our walls, we have cedar siding. Underneath our slab, we have 4 inches of insulation, so we have a very tightly wrapped building envelope. And because all of our mechanicals are on the inside of the building, then our walls and our roof, for the most part, can be solid, and we have very few penetrations that can transfer energy in those wall systems. I just want to say that, so we've talked about our drinking water in the building, we talked about our black water in the building, we talked a little bit about storm water in the building, or outside the building, hopefully. But we did not talk about gray water in the building. So we do have a gray water system here. So obviously that's the water that goes down our sinks. It goes into a septic system outside, to a sand trap filter, and then gravity feeds into our constructed wetland. From the constructed wetland, if there's an overflow or an excess of water, it can go into our leach field. So that is a pilot system for us. So we do have the septic tank and the leach field, and it's interrupted by the constructed wetland.
So you don't use it for flushing the toilets? Or
We do not.
for spraying water into the composter downstairs?
Nope. It only goes back and transpires back into the environment.
What do you use it for?
We don't use the gray water.
Oh, yeah.
I mean, it's from our rain, right. When we get our water system up and running, it will be from our rainwater to the sinks and then back into the gray water system. And then either transpired, or if excess, goes into the leach field down into the ground.
And the
So we're just letting it go.
The excess for your reservoir now goes into the leach field too?
The excess from our reservoir, so our reservoir does have a flow-through capability, so we don't have standing water in there. And so that overflow goes into our bioswale. So then it just filtrates back into the ground. Yeah, yeah. So one last thing, when we did move here to this site in Hampshire, as much of this part of Amherst was, it was an apple orchard at one time, and they used a lead arsenic spray on the orchards, and so we had arsenic contamination in our soil here, and we decided to do a 7 to 9 inch removal across the entire site, scraping off of that soil. We did bury it in our parking lot, so it's here on site. We didn't have to spend time or money or energy chucking it away, but then we had to bring in clean fill to replace what we had taken away. And then we've been planting native species to do a recovery on our site. And if you were here last summer, it was full of pollinators because we had flowers everywhere in our field out front and all around. So we do have trails that go out into Hampshire's campus, which all of our programs use. We do have around this play area here, we have a mud kitchen. We've got some uneven logs. We have some willow structures. So we're growing some willow trees. We planted stakes last spring. So they'll be growing into willows, and then we'll weave them together to form a structure so that the kids can go inside and have a little play space. And then we're finishing up with some additional teaching areas outside, which are yet to come. So thank you for coming on the tour today. I'm happy to hang out and answer any questions, or you can challenge me on things that I have yet to learn still. But you're also free to head out if you'd like to.
Thank you.
Thank you.
Thank you. Yeah.
Thank you.